This is Note-Taking Guide 4.7, and it's solving systems of equations by elimination. Now, I've already taught you how to solve a system of equations by graphing and finding the point of intersection. And then last note-taking guide, I showed you how to solve a system of equations by substitution method. So this is just a third method on how to do the exact same thing. So solving by the elimination method, the elimination method says this. It says I'm going to look at my two equations and I'm going to see if I can add them straight down the way that they are to get something to cancel. Now this particular problem is set up beautifully for that because we planned it that way. But if you see right here in the middle, you have a negative 2y and a positive 2y, which will cancel each other out if you add them straight down. So that's what we're going to do. We're going to combine like terms by adding straight down on the system of equations. So right here, when I do 3x plus 4x, I get 7x. Right here, the y's cancel each other out. And then over here, 4 plus 10 is 14. Now I'm going to divide both sides by 7 to solve for x, and I get x equals 2. Now, just like the last 2 days worth of notes, in order to actually have my solution, I need an ordered pair in the form x comma y. Right now I only have an x value, so I have to take that x value and substitute it back up into one of my equations up here in order to find my y value. So I'm going to do 3 times 2 minus 2y equals 4. And I'm going to solve that to find my y value. So 3 times 2 is 6. 6 minus 2y equals 4. Solving this equation now for y, which means get rid of the 6 first. So I'm going to subtract the 6 over to the other side. It cancels over here, which is why I did it. So I just need to rewrite the negative 2y. And over here I get negative 2. I divide both sides by negative 2 now. Cancels over here, and I get y equals positive 1. So my ordered pair answer in x comma y form is 2 comma 1. So again, the elimination method says try to add the two equations straight down so that something will cancel. Now this one again was set up really nice for us. I'm going to have to show you what to do when that doesn't happen. So here's a problem that when we add those straight down, if we add the x's right here, we're going to get 2x. If we add the y's right there, we're going to get 3y, so nothing cancels. The elimination method wants us to add straight down so that something will cancel. But the rule also says if we can figure out a number to multiply through by so we can add straight down and have something cancel, then we're going to do that. So if I had one of these x's right here be a negative x, so that one was a positive 1x and one was a negative 1x, then I could totally add those straight down and have them cancel. So that's what I want to do. I want to figure out what I need to multiply one of the equations through by to get them to cancel. Well, if this is a positive 1 out here, if I take negative 1 and multiply it through the entire equation, then it will give me that negative x that I need to be able to add straight down and cancel. So this is the way I like to do it. I like to find the number I need to multiply through by, and I like to multiply through by it on the equation. So a negative 1 times a negative 1x, or a negative 1 times a positive 1x is a negative 1x. A negative 1 times a positive 2y is a negative 2y. And a negative 1 times 25 is a negative 25. So what I did was I took this negative 1 right here and I multiplied it through the entire equation. When I'm done doing that, I like to cross out that equation so I remember not to use it when I'm adding straight down. So now I'm just going to add my original equation on the top right here, this one, with my new equation that I wrote on the bottom, and let's see what we get. So adding those straight down, we now have x plus negative x, which would be 0 x's. They're gone. I have 1y minus 2y, which would be a negative 1y. And I have 18 minus 25, which would be a negative 7. Now this is really easy to solve from here because all I have to do is get rid of the -1 on the y, and I get y equals +7. Now I have kind of a mess up here because I did a lot of stuff to show you guys what I was doing, so I'm just going to erase that for a minute so we can see what's up there. But what I'm really going to do now is take that 7 and substitute it back up here in place of the y and finish solving that. So I'll have x, and instead of plus y, I'm going to have +7 equals 18. Oh my goodness, I keep messing up over here, not letting me write. So let me move this. X plus 7 equals 18. I'm going to subtract the 7 to the other side, and I get x equals 11. So just like before, my answer is in an ordered pair, x comma y, so 11 comma 7. Alright, so again, this is called the elimination method. I'm trying to get my equations to add straight down and cancel the way that they are. So I'm going to look at these and see if they'll add straight down here or here and cancel a variable. And they actually do right there with the y's, so I'm good to just add them straight down. So I have 2x plus 3x, which is 5x. I have positive 2y and a negative 2y, which cancel each other out. And then on the other side, -2 plus 12, which is positive 10. Divide both sides by 5, and I get x equals 2. I'm not done yet, though, because I have to take that 2, and I have to substitute it back up into one of my top equations. It doesn't matter which one you choose. I just usually put it in the top one unless the other one looks easier. So putting it back up into that top one would be 2 times x, but my x is 2. Plus 2y equals -2. 2 times 2 is 4, so I have 4 plus 2y equals -2. I'm going to minus the 4 over, so I get 2y equals -6. Divide both sides by 2, and I get y equals -3. So my solution to this system of equations is my x comma y ordered pair, which if I were to graph it would be my point of intersection between those two lines. So 2 comma -3. Alright, this is a checkpoint problem, so if you'll please take a minute right now and pause the video so you can try this one on your own. Then you can check your work with mine. Okay, let's take this one and just check and see if we can add it straight down the way that it is. If I add those straight down, I get 6x. But if I add my y straight down, they're going to cancel. So that's what I'm going to do. I'm going to add these straight down and see if they'll cancel. So 4x plus 2x is 6x. And 3y minus 3y is 0, so those are gone. 24 plus 12 is 36. So this was a really nice, easy one. I'm going to divide both sides by 6, and it cancels over here to be x, and over here 36 divided by 6 is another 6. So I'm not done yet. I have to take that 6 and I have to substitute it back up into the top equation so that I can get my solution. So I'm going to have 4 times 6, because 4 times x, plus 3y equals 24, and I'm going to solve that. 4 times 6 is 24. Plus 3y equals 24. To isolate that y, the first thing I need to move is the 24, so I'm going to subtract it to the other side, which gets me a 0 over here, and it gets me a 0 over here. Now don't get this confused with those ones a little bit ago where I said if it was a false statement, then it was undefined. If it was a true statement, then it was many solutions. Because this time I actually still have a y that I'm solving for. So to isolate the y, I'm still going to divide by 3. And 0 divided by 3, punch that in your calculator really fast. 0 divided by 3 is just 0. So it's totally fine to just do that. And our answer is going to be 6 comma 0. Alright, this is the last problem on the checkpoint. So again, you're going to look and see if you can just multiply through by a number on one of these two equations. so that you can add these straight down to have something cancel. So when I look at these, the 6s, they seem really easy to cancel because they're both the same number already. I just need to get them opposite signs. But I could also get the y's to cancel if I wanted to. I would have to times the top equation through by 7 and the bottom equation through by 5. So you can totally do it that way if you want to. You can choose which variable you want to cancel. But because the 6s are the same number, I'm going to just choose to multiply one of these through by a -1. I'm going to do it to the bottom equation. So I'm going to take the -1 and just multiply it through. I'm going to have a -6x when I do that, a positive 7y, and a positive 20. Again, I like to just cross that out and then add these two straight down. You know how I am. I like to take the easy way out or do the least amount of work as possible. So try to write this really nice so you can see what you're doing. But 6x minus 6x cancels. 5y plus 7y is 12y. And 4 plus 20 is 24. To get the y by itself, we're going to divide both sides by 12. And I get y equals 2. I'm still not done though. Wish I was, but I'm not. I got to take this 2 and I got to substitute it up into that equation, one of the two equations in place of the y. So I'm going to have 6 times x plus 5 times y, our y is 2, equals 4. And I'm going to finish solving that equation. So 6x plus 10 equals 4. Minus the 10 to the other side. So I get 6x equals -6. Divide both sides by 6. Cancels on that side and I get x equals -1 from the -6 divided by 6. So my ordered pair solution is -1, +2. Now just a point to be brought up, because the two examples that I did show you on this note-taking guide, we only had to multiply through by a -1, but sometimes you do have to multiply through by different numbers. So I want to show you an example of that. So if you'll flip your paper over where you have some spot to write, I would like to show you one more example of how we're going to do that. Alright, so this is number 2 on your worksheet. So when you get your worksheet today, this is number 2. You're going to have 2x plus 7y equals 1, and x plus 5y equals 2. Now if you notice this, if you were to add them straight down right here, neither of them are going to cancel the variables out. So we have to decide what we're going to multiply through by in order to get our variables to cancel. So this to me looks really easy to try to make this a 2 and a -2. So what I'm thinking here is that if I can multiply this equation through by a -2, then I can get the right number in front right there to add those straight down and have them cancel. So if I multiply through by a -2, I'll have a -2x, a -10y, and a -4. Again, I like to just cross that one out that I'm not going to use anymore so I can add straight down. It's a little bit messy to look at, but right here our 2x and our -2x are going to cancel. And then I'll have 7y minus 10y, which is a -3y, and 1 plus a -4, which is a -3. Solve by dividing both sides by -3, and I get y equals 1. Now I'm not going to take the time to do this for you, but you do just take that y and you're going to substitute it back up into one of your two original equations to find your ordered pair solution. So right now we only have part of our ordered pair. We have the back part. You're going to substitute it back in to find your original. Point being on this though is that it's not always -1 you're going to multiply through by. It could be any number. And sometimes you're going to have to multiply both equations through by a number. So just a really quick hint on, say, number 9 on your worksheet. On number 9, you have 2x plus 5y equals 11. And you have 4x plus 3y equals 1. In order to get this to work, you could take these x's here and make them both 4s by multiplying the top through by a -2. Or if you wanted to go completely different because you don't want to get rid of the x's this time, you could take and multiply this one through by a 5 and this one through by a -3 to get this to be a -15. And to get this to be a +15. So you really can multiply by any numbers that you want to as long as you do it through the entire equation. Okay, so pick your x, pick your y, it doesn't matter which one, but multiply through by a number to get them to eliminate by adding straight down. All right, good luck on your worksheet, you guys.